Hi, welcome to this presentation on claim, evidence, and reasoning. The goal of this presentation is for you to have a general understanding of what goes in those sections of the lab report, and also to explain how reasoning is used to explain our evidence and our claim with scientific principles. So we have the example of a murder mystery, and our question was, did Mr. X commit the crime? Now, Mr. X was the brother of the chef who worked at the wealthy old man's house. And we talked about a variety of information and collected evidence to find out whether we thought he did the crime or not. Now in science there's a really similar process, and we're not necessarily trying to find out if someone's guilty or innocent of a crime, but rather we're trying to answer a scientific question by collecting evidence and then explaining that evidence. So this is the same kind of process. On the report then, we have our claim, our evidence, and our reasoning sections. Now we do these after we've collected the data. So we've asked a question, we've gone out, we've followed a procedure to investigate it, and now we have to make sense of it and write our claim. So our claim is just the answer to the scientific question. Our evidence and reasoning then support the claim. They relate to the claim. So evidence is basically any kind of scientific observation, and reasoning is using scientific principles to explain that evidence or to explain how our evidence relates to the claim. In terms of using scientific reasoning, we could think of it then as having sort of three levels. One is this idea of big scientific ideas, such as laws and theories and principles. And this is for the gel electrophoresis lab. This is information you would get from the reading or from the background videos. We also then might have some supporting details, things that are relevant to our question coming from those big ideas. And then lastly, and maybe most importantly, we have to connect those big scientific ideas to our actual claim and our evidence. So here's an example. Here's a claim from the murder mystery. It says, with chef's help, Mr. X committed the murder at 8 p.m. by choking the victim in the dining room. So I'm trying to provide as specific a claim as I can here. And with that, once I make that claim, then I have to provide some evidence and reasoning to support it. So here's some evidence. If I found that Mr. X's fingerprint was on the outside of a broken piece of glass in the room, then what I would have to do is explain that. So I could use a general scientific principle, which is that fingerprints are unique for each individual. Right? That's like a general rule. Now, because fingerprints are unique for each individual, I could conclude, and then I might add the detail, that the fingerprint on the glass matched Mr. X, and therefore he must have been in the room. So if you look over there on the right, in red, I have the general scientific principle that fingerprints are unique. In orange, I have the supporting detail that the fingerprint matched Mr. X, and then I tie that reasoning to my claim specifically into the piece of evidence by stating that he must have been in the room. There's no one else that could have left that fingerprint there. Let's look at another example from the murder mystery. On the knife, chef's fingerprint is layered on top of the victim's fingerprint. So I start with a general scientific principle, you can see there in red, which is that oils are broken down by soap and scrubbing, and that fingerprints contain oil. Right? The conclusion I might draw from that then is that a clean knife could not have prints on it. So if the knife had the fingerprint on top of the victim's, then it couldn't be there from some previous time, because when the knife was washed in the kitchen and before when it was served, the previous fingerprints would have been washed away. And then lastly, in yellow, you see I tie that reasoning directly to my claim and to my evidence by stating that the chef must have handled the knife after the victim began eating. He couldn't have handled it before because his fingerprints would be on the bottom and not on the top. So you can see these three different layers, right? A general scientific rule, some supporting details or conclusions that I could draw from that rule, and then connect it directly to my claim and evidence. Here's a claim from our gel electrophoresis. I might claim that gel electrophoresis can be used to identify a person by separating strands of DNA with unique properties. So my question was, how could it be used? Well, I'm saying it can be used by separating strands of DNA with unique properties. Here's an example of a piece of evidence in this case. Now, I don't have any data in this experiment with gel electrophoresis, such as averages or best fit lines or anything like that. But I do have concrete observations, things that I actually observed in the lab. For example, each test solution contained molecules with unique properties. Each test solution was a different color. So my reasoning then might start off with a general idea that color is a property of matter, and since each solution had a unique color, the dye molecules must be different. If the molecules were the same, each solution would have been the same color. I connect that then directly to my claim and evidence by saying that when DNA, so trying to make the jump now to how I could use electrophoresis to identify a person with DNA, when DNA is cut into pieces with restriction enzymes, strands of different sizes are produced based on each individual's unique DNA sequence. So because all of us have slight differences in our DNA, when we cut up our DNA with restriction enzymes, the pieces are going to have different properties, or in this case, different lengths. Here are some other possible observations you might have from the gel electrophoresis lab. The movement of the dyes toward one end of the electrophoresis chamber. A second might be that the molecules separate into bands at different distances, with each band being different color. And also you might have noticed that the mystery solutions appeared to be separated into multiple bands that matched some of the bands of other solutions. So they didn't just separate into random ones, they separated into bands of known solutions where we knew the color. So your job then would be to think of what are the general scientific principles that could explain these pieces of evidence, and then connect it to our question about DNA. So I hope you found this helpful. You'll need to use the reading and the videos for background information, and then use that information to write a really good claim, evidence, and reasoning section for your report.